Okay, so I'm going to do this video to basically guide you through the basic use of R. Okay, so it will be actually, let me just go and share my screen first. So when you use R, this is what you end up with. Just let me grab this out. Okay. So when you actually go to your tutorial, there's a lab 7, which is an e-tutorial on introduction to R. Okay, so I presume you have R installed already. If you do not have R installed, please go and install it yourself. You can just go to find R project. Okay, go to R project, and you will be able to download for R for Windows or for Mac, up to you. Okay, so R, download it. And after you install R, I prefer you to also install R Studio. Okay, so you go to R Studio download. R Studio, you can install it. Okay, so here we'll be using R Studio, so I have R Studio here. If you use the wrong one and you use only R, it's still workable, just that it is more rudimentary. So you click on R here, get R x64, so R will look like that. Okay, so R Studio is a little bit more sophisticated in that sense. Okay, let's do a save and let's get to here. So my very first part is, let me just go through the notes itself. Okay, I want to enter data. Okay, to enter data, first I have to create a data frame. A data frame is essentially just like an Excel spreadsheet. Okay, I assign the data frame to my data. Okay, have to be small, or I tend not to use this. I tend to use equal. Okay, so let's say I assign the data frame to my data. A bit too much stuff. Assign to my data. So now you can see that my data has 0 observations, 0 variables. Okay. Then what I want to put my data in is I have to use the edit command. Okay. Then after the addition, after I edit my data, I put it inside my data again. So here, what I do is edit my data, and then I press enter. It will generate a data editor. So this is where I start to use my stuff. Okay, I can change the variable name. Variable name, I say that, okay, let me just get closer to here. This doesn't really bother me, but let me just get this closer. Okay. So I want before and after. Okay, so let me just enter the values in. My data editor is here. Okay, and here I want before. So now it's before. Okay, and then I want the next one is after. After that, I just key my data. So before is 84, enter 60, 75, 72, 68, 54, 52, 45, 77, 69, 66. Okay, so I have 10 of them, correct. So after I have 80, 55, 72, 65, 68, 55, 49, 70, 68, and 59. Okay, so that's it. Once I'm done with it, I will just close this. So how do I make sure that my data is actually entered properly? I just ask it to give me my data. So we have my data here, before, after. So all your data is entered properly already. So then I can go to my analysis. Okay. But you have to know that, let's say you enter data here, it doesn't get stored. So once you close R Studio, it will disappear. So usually we seldom want to do that. We tend to put our data into an Excel spreadsheet first. Okay, so for example, we take this pulse file which is inside your data under lab 7 data files. There's this pulse. So let's open in Excel to see how does it look like. Okay, so this is an Excel workbook. All right, so now it gives us a list of data, height, weight, and so on. Okay, so how do I read it? Number one is you have to go inside R and change the folder. You make sure you're in the correct folder. So you go to Tools, not Tools, Session, Set Working Directory. Then you choose the directory. Okay, same here. Choose the directory to where you are, where the data is. So I put inside my DB course notes, biological data analysis, record manual, R7, and data file. Okay. Then after that, it shows nothing. Okay, so you open it, and here, this is your file explorer to some extent. What you want is how do you read the file? Okay, very simply, if it's an Excel file, just import. You can double click on it or click once. Import data set. Once you import data set, okay, requires you to install something. Okay, then just install it. Okay, so it takes a few moments for it to install. Yeah, so things that are missing, it will try to install for you. So R is quite good with that. Okay. Now, what you end up with is the data itself. So you read the default sheet. The default sheet is sheet 1. So it's retrieving. Okay, just let it run for a little while. This is Excel. Okay, because I've opened it, I cannot reopen it again. So let's close it. Close this Excel file. Okay. So then what you do is you try to open it again. You import. Okay, so here I kind of messed it up. So I kind of import the data set all over again. Okay. So that's previewing. Okay, so now you have previewed the data. Does it look right? Okay. If it looks right, then here it actually says that the file, read Excel, the file is actually, the data set is read into pulse. Okay. So you import it. Make sure that it looks okay. After you import it, then you have this pulse data. Okay. There's 110 observations, 11 variables. So this is the data view. Does it look right? If it looks right, then kind of close it. You don't really need it. So what you end up with is this command window is very important here. Okay, everything shows up in command window. So let's move it a little bit more to show you a bit more space. Okay, what you need to do first is you can actually look at the data. Okay, so how does the data look like? You can actually kind of do a head on pulse. So you view the first few lines of pulse. Does it look correct to you? If it looks correct, then that's fine. Then what you do is, inside each one, this is the columns, correct? This is header rows. Okay. So you can actually do the average. For example, I want to find the average of height. I will just use this concept, the data itself, $sign. So what I need is pulse, because my data set is called pulse. $sign, I have, let's say, what is the height? Okay, and I want the average. So I wrap this up and call it mean. Mean is average. Okay, so you have to kind of look through at the end here. And now the average for height is 171.5818. Okay, so you can actually calculate the average here. Now, very often what happens is you may have data set that is missing. Okay, for example, let's say here give me I want to find the average for the first pulse. Average for first pulse, it gives me a, need to redo it again, copy too much stuff. Okay, not data 2, pulse. Okay, it tells me that there is an error because some of it has no data. So let's look at our Excel again. After you import, you can go back and look at Excel. So let's look at the column. Okay. Now we find the column pulse. Okay. There is one of them that is NA. So R doesn't actually remove it for us. So we have to clean the data ourselves. How do we clean the data? Basically, I want a pulse. Okay, so I can call a variable clean pulse. Basically, I want to remove all the NA omit from the pulse data set. Okay, so let's go here. So my clean pulse, for me, I tend to use equal. And then this is my pulse data set. Okay. That's it. Okay. So let's look at the data here. Okay. The clean pulse still have 110 observations, but then that's fine. Okay. Okay, so we can actually do a cleaning for the data itself. Sometimes you want to do subsetting. Subsetting means that can we actually isolate a part of it? That means can I only pull out all those people who smoke 2 cigarettes a day? So I can pull out those people. Okay, variable whether smokes or not. Okay, so non-smoker. Let's see what does it say here. Okay. So I can say that two instead of non-smoker, I can say smokes 2. Okay, and so on. So I can actually pull the data out for those that smokes, let's say that the smokes, column smokes is actually equals to 2. Okay, so here I change it. And I say, instead of non-smoker, I say smoke 2. Okay, make my life easier. Okay, then press enter. So how many data set, how many rows do I have? I have 99 observations of those that smokes 2. Okay, so I can actually do a subsetting of the data this way. Basically, it means that if I were to arrange these columns, let's say I were to sort based on smokes, okay, and I sort based on largest, smallest. If I go all the way down, see, this gives me 100th row. That means there are 99 data observations, then 9 rows. That is smoke equals to 2, okay, which actually means here. So you can subset a few more things. Okay, for example, I can subset, let's say, smoke 2 and exercise 2, whatever that means. Okay, or all those that is 18 years old and smokes 2 cigarettes a day. Okay, I can do that. How do I do it? I can say smokes 2, exercise 2. 2, and so on. Okay, but I will not do that. You can actually take based on the smokes 2, then you kind of do it one step at a time. Okay, so I can actually use the data that is in smokes 2 already, and then I say that I want exercise equals to 2. Okay, so here exercise equals to 2. So it's much easier to do a stepwise reduction. So I've only now 53 variables, or 53, a sample of 53. Okay. I can also construct new data, because BMI, I can actually use the height and weight. So here I have my height and weight. Okay. Now my height is in centimeters, my weight is in kilograms. So the equation that I need is I have to multiply 0.01 so that I convert my height from centimeters to meters. Okay, and then I put it with this. So let me just copy down this row. Okay, remember this column here. Now I say that my BMI calculation. Now this is data. So I change it to pulse again. Pulse. Okay. So basically what this means is, using the data pulse, okay, my BMI is calculated by the weight column divide by 0.1 times the height square. Okay, so this gives me the BMI. And now I can actually check what is the average BMI. Correct? Pulse BMI. So this is my average BMI. Is that correct? You know, I can run through here and check whether it's right or wrong. Okay, so these are the basics way of looking at Excel. R. You can use R for a lot of different purposes. So R is programming language by itself. It's mainly used for statistics. Here I leave it to you up to do. You can actually look at whether it's a tall, medium, or short, or tall, average, or short, based on looking at the data. So I can actually use do a summary. So a summary of any variable. Let's say I do a summary of my BMI. Okay. What the summary of BMI actually do? Let's run it and see what happens. Okay. It gives me the minimum value, first quartile, median, mean, third quartile, and maximum. So this gives me the 5-number summary, 5-digit summary. Okay, plus the mean as well. So it can be quite useful for that. So R is actually a learning of different commands that you need and just use it appropriately. Okay. So we can actually do hypothesis testing if we wanted to. We want to do hypothesis testing. Okay. For example, we can do hypothesis testing on different data sets. Okay. Let us just use this data set from this BDA data set. Okay, so we install the package. Okay, so this is also how you can install package in R. Please change it to this inverted commas. Okay, so install the package. So this is what happened. Just keep installing. Once this package is installed, then you can use it. Okay. Before you use it, you have to load the library first. Okay. Or you load the package using this library command. Load it. So now you will load all the required packages for you. Then you can perform your Z test. Okay, you test for one mean and so on. So what does it do? Okay. So let us take this. My data to H. Okay. So I'm going to use for my pulse data. I calculate a standard deviation for my pulse data. So I basically calculate the standard deviation for the age. Okay. Essentially the standard deviation for the age column. So if that is the case, what is my standard deviation for age? My standard deviation for age is almost 4 years. Then I can do a t-test. To do a z-test. So I do a z-test. Let me just show you how, step by step, what does it mean. I copy down this. Now, what does this command mean? Okay. First, I will take my x value. What am I trying to calculate? I'm trying to calculate my pulse age. The y value is none. Okay. So I have two tail. Alternative is two tail. The mu, that means the alpha, or the average is it equals to 20. So in this case, I want to test is that mean age equals to 20 years old. That's why I don't have the y. If I have the y, I will calculate it as a 2 samples z-test. Okay? So the mu is 20, which means that the average of age minus the mu. The sigma is s, and then of course the sigma of y x is s, because I calculated here the standard deviation. The sigma of y is nothing. And my confidence interval, which is 95% confidence. Okay, so you have to know each one, what does it really mean. Okay, so then it gives us a one sample t-test, a one sample z-test. Basically, my data is my pulse age, the z value, the p-value. So based on this p-value, it tells me that the null hypothesis is, this is actually the null hypothesis. Okay, it tells me the p-value, then I accept or reject the null hypothesis. Because my p-value is less than or more than 0.05, I cannot reject the null hypothesis. I have to accept null hypothesis. Means that the true mean is actually 20. It's also important to note that you calculate the mean for you. If the 95% confidence interval encompasses, that means it's within, it's flanking the mu that you want, it is never going to be significant. Okay, so you can do your one sample z-test this way. All right, so it gives you the data. You can also do a t-test. Okay. T-test is also very similar. For example, I can do a t-test. Let's say I have another data set. Okay. Now I want to read another data set, which is cholesterol, this cholesterol file. So I have day 2, day 4, day 2, day 4, and day 14, assuming that they are the same person. So I'm measuring the cholesterol for the same person over different days. Okay. Similarly, cholesterol, make my life easier, I just click. So I try to read the data in. Okay. The easiest way then is to use this read table command. Okay. So I read the table. Okay, the table is giving the file name cholesterol.txt, and the header is true. Because why the header is true? If you look at the data itself, I have a header row. That's why the header is true. Okay. So let me read it. Now you have the cholesterol inside here. You can actually just double click on it and view the cholesterol data to see whether does it look right to you. Okay. If it looks right, then close it. What I can do is I can actually check whether is there a difference between the cholesterol level on week 2 versus week 4. Now, because it's the same patient, I can use a PET-T test. Okay, so let me just copy down this whole thing, and I explain each variable to you. Okay, first, my x, I have two values, my x and y, similar to how you use it in Excel as well, your x and y. So my x is day 2, my y is day 4. I use a two-tail test. My mu is 0. PET is true, so I'm using a PET-T test. Okay. Equal variance, whether am I assuming equal variance? I assume equal variance to be false. Okay, confidence level is 95%. So then it calculates a paired t-test for me. Okay, so then you have from data day 2 and day 4, this is your t statistic, and the p-value is 0.003, which means that you reject the null hypothesis that the average, that there is no difference between day 2 and day 4, because there's a difference by itself. Okay, what will happen if, let's say, you change, if you want to go up, let's say instead of you want to repeat this instruction, so you can just press the up button. What happens if I were to change paired to false? Let's try it. You will actually do a 2 samples t-test. Okay, 2 samples t-test. Of course, there are 2 versions of it. Remember, you have your equal variance and unequal variance. Here we do an unequal variance t-test because equal variance is false. If you want to do an equal variance t-test, we will change that variance equal to true. So you see, then it gives you 2 samples test. The p-value is the same. In fact, there's not much difference. Okay, just the degrees of freedom is slightly different. So there is a bit of difference between your Excel and R, because R use a Welsh 2 samples t-test when you have an unequal variance. All right. Okay. So you can go on and do a few others, but remember what we also want is, we have done before, is to check whether is the variance equal or not. In Excel, you use your F-test for equality of variance. Okay, but here we use a test called variance test. Essentially, it does F-test as well. Okay, so let's run this. And what does it mean? Okay. I'm sure you can guess what the command means already. Variance test, checking for the equality of variance. Of course, this is something that you have to learn along the way, all the different commands. You check between day 2 and day 4. Confidence is 0.95. Then you run it. Okay. So it do a F-test comparing the equality of variance, and the p-value is 0.9, which means that you assume the variance to be equal. Okay, so kind of this is a quick summary of how you do statistical tests using R. Okay, but I know that it is very scary because of all the commands that you type in. Okay, remember in Excel, if you ask, if it doesn't have the data analysis tab, you also have to type in all the commands. Okay. So if you need to do something, you can always ask Mr. Google. Let's say R. You can actually say do a, let's say, t-test in R. Okay, there will be a lot of information to teach you how to do a t-test in R. For example, here that says quick R. Okay, it actually tells you how to do a different t-test in R. So test 1 versus test 2, head, you have a mu. So this is exactly what I've done just now. Make sense? Or you can go to the R function itself, the documentation. It also tells you how to use R. Okay, so this is exactly what we do, and it tells you what are the arguments that you put in. So some of it we have the arguments. Okay. Then it gives you some examples. So here you can actually run it yourself if you want to try. Okay, so R is very sophisticated. It does a lot of different things. So let's say, for example, t-test R, right? Remember, that's just one of the many pages. You can actually do your regression, which will be actually learning. Non-parametric tests will also be learning as well, and so on and so forth. Okay? You can do your descriptive statistics. Okay. You can do summary, we have already done that. Okay. So it can be quite useful for us to show what data that we want and so on and so forth. Okay. So R has a steep learning slope, yes, but it is good that you learn R because Excel has its limitation. SPSS is expensive, so unless you are in a rich place, a company that wants to pay for it, usually you only end up with tools like R. So R is actually not easy, but it is usable. Okay, so that's all for today. Hopefully you can try it out yourself. In fact, the commands are actually listed here. Read through and practice. Okay, that's all that I have for you. Thank you very much.